Hi guys, am I audible to you?
Yes, ma'am.
Yes,
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 ma'am.
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 Okay, got it. So today is the presentation. So who wants to present? Just let me know
Ma'am
your name.
Priyanshu.
I'll do it, ma'am,
Ma'am, may.
if you don't mind.
Okay, just a minute. So Priyanshu wants to do. Okay, Priyanshu, then Fida.
Ma'am Hasini.
Okay, Asani. Ranvijay Singh. Yeah, Ranvijay, you want to present? You can switch on your mic and tell me.
Yes, ma'am. I can do that. But there is
Okay,
too much
okay.
noise. Too much noise, ma'am. Because we are in factory. Let me try to do it. If audible, we'll
Oh,
continue, ma'am.
yeah, it is audible, not an issue, Ranvijay. We can
Okay,
go ahead. After Hasini, you can just present. Fine.
ma'am.
Okay, anyone else? Guys,
Hello, ma'am.
yeah,
Is it visible to my screen?
yeah, your screen is visible. So,
Okay, ma'am. Yes.
you want to present first?
Yeah, ma'am. Let me finish it because there is and we have to go to some place.
Okay, fine. You can just present. You can continue. Your screen is visible.
So we'll.
Yeah,
Hello.
Ranvijay, your voice is actually breaking.
Yeah, ma'am. Anyway, now is it visible, ma'am? And is it audible?
Yeah, yeah,
Okay,
you can
let me do
continue.
it. Yeah, so today we are doing this, ma'am. We presenting week 5 project, and we are predicting the heart disease prediction using artificial neural network. So here is my task. We are taking the data cleavage data set from this GitHub, and we are using the model of single layer perceptron and multi-layer perceptron. These two methods we are using here. So after that, this here we are just describing, we are loading the data, cleavage data set. Here we have loaded the data. Here we are just checking what is the head, what is the information, and what is the describe. After putting this code, we are getting this all these things. There is a they are getting this def data frame head, and there is a total uh, column and the rows. This here we are just counting mean, stadium, minimum. This here we are doing all that. After that we are doing the just pre-processing of the data. So here we are doing the pre-processing. Here we are loading the library of sklearn selection. Here we are doing the selection, pre-processing, and compose. So here we are just doing the data of the variable separating. Here we are just taking the x and y value. So this is the my x value, df dot drop target axis 1 and df target. Hello, am I audible, ma'am?
Yeah, you're audible. Continue.
Okay. Then here we are just categorical numerical features. So here we are doing the categorical features. Here we are doing the features like this sets, and this is all this. I think this is the data of this issues. We are not this is short form. We just taken the data from this. We don't know what is this medical lines terms. So here we are just taking this because it is mentioned on my data. So here we are just taking the numerical values, age, test, and see all old pick whatever. Create transform for numerical and categorical features. So here we are just doing this transformation. What the categorical features, numerical transfer, we are taking standard scalar and this transformation here. After that, we are just doing the create column transformer to apply different transformation to different columns. So here we are just doing the preprocessor where we are taking the is data num cat. After putting the code, then again we are applying the pre-processing. Here we are just taking the X process. After that, we are doing this split the data for the testing. So here we are just taking the X train, X test, Y train, Y test, and these all the values we are taking the here. Total size is 0.2 and random state 42. So here we are just putting the value X train, X test, Y train, and Y test. So after this putting the code, we are just getting this value. This is my X train 242 30 E61 30 242 0 and Y test 61 0. After that, we are just selecting the model. So here we are just selecting the model by the help of single layer perceptron and multi-layer perceptron, and it is the part of the multi-layer perceptron of the feed forward network. So just we are also considering this. So here we are just doing the my task using the TensorFlow. Here we are using the TensorFlow. So here we are importing the library TensorFlow as TF, and the model also we are using the keras. So after this, we are just putting the training the data of input shape as train shape. After that, we are applying the multi-layer perceptron because it is a part of the FFN model. So we are doing the multi-layer perceptron. We are doing the model. Here we are giving the value and we are using the method of the ReLU. Here we are ReLU, and here we are using the sigmoid. After that, we are just taking the model, creating the model. So here we are just taking multi-layer perceptron FFN model. We are just taking and just we are taking the summary. After that, we are getting this output data. Here is layer type dense and output shape none 128 and param is 3962. It is all as it is showing the different values. So total params is 14337 and trainable params is 14337 and non-trainable params is 0. After that, we are using the SLP model. So here we are just creating the SLP model. We are use the activation function of the sigmoid. After that, we are creating the model SLP model. Then we are displaying the summary. So after that, putting the code, we are getting this output. Here is layer type dense 4 dense. Here is the output shape is showing none 1 and parents is showing 31. So after this, we are just doing the part of the training. So here we are just doing the training. So train the SLP and MLP model using the training dataset display and parameter storing the training history of each. So here we are just using the TensorFlow and Keras libraries. Here we are again training the data. After that, we define the SLP model, and here we are using the activation function of sigmoid. After that, we are just here we'll finish it one SLP model. Then again we are same as it is are doing the MLP model. So after this, we are just creating the model SLP model and MLP model. After that, we are just doing the training the model. So here we are just putting the after training SLP model and MLP model both. We are training here, then we are getting this MLP model train finish, SLP model train finish. After that, we are just plotting this uh, plot. So we are using the matplotlib. So here we are just training the history of SLP model. We are just plotting the model of the SLP and this MLP both we are drawing there. So after putting this, so we are getting this output of x-axis is epoch and y-axis is accuracy. So here my data is varying 0. I think 32 something here 0.8. I will come it for after 5 minutes. Wait, yes. Okay, coming. I'm coming 5 minutes. SLP model loss. Then after that, here we are taking this x data epoch and y is losing SLP model loss. Then here also is showing the MLP model accuracy. Y is we are taking the accuracy, X is again epoch. Here MLP model losses is showing. We are taking this Y value of the loss and X value of the epoch. This graph is showing here. After that, we are doing the evaluation. So here we are importing this matrix, sklearn matrix. After that, we are importing. Here we are doing the part of the evaluation. So we are evaluating the SLP model and we are evaluating the MLP model. We are just typing the simple code. After that, we are just getting the output SLP model evaluation. This one accuracy is showing 88% and precision is showing 93%. Recall is showing 84. F1 score is coming 88. So confusion metric is showing like that. And the MLP model evaluation is showing 81 and precision. His precision is showing 81 and recall value is showing 84%. F1 score is showing 83%. Confusion matrix is showing like that. So we are just comparing the model after we have summarized and comparing performance model. We are just comparing the model of the SLP and MLP model. Both model we are comparing. So after comparing everything, we are getting this again. This value is showing as it is same. After that, we are doing this. This is the part of this. Then here is a summary. Summary is showing that data analytics key findings. So here we are, our data is, I think, not bad. It is showing this good approximately accuracy approximately showing. For the SLP model, it is showing 88.5%. Precision is showing 93%, 84%, and F1 is showing 50%. And the MLP model is showing this approximately 81.97, precision of 81.88, and the F1 score is showing 83.
Your voice
So these
is
are my
breaking in
conclusion.
between. Your voice is breaking. Just go ahead with the last part with the
Hello.
SLP. Yeah, now it is fine. Just go ahead with the SLP model, like the summary part. Just go ahead with the
Yes,
summary part once.
this is the summary. So we are just taking the summary. We are just comparing the model of the SLP and NLP. So here is not showing the bad performance. It is showing the good performance because the SLP model is approximately accuracy is 88.52 and of the precision is 98.10. Recall value is 84.38 and F1 score is 88.52. And as MLP model is also showing this good accuracy 88. 0.97, precision is 81.82, recall is 84.38, and F1 score is 83.08. So it is the not we are doing this good, this data is going the good insights. So thank you for the presentation. It is enough, ma'am. Hello.
Okay, got it. Got it. So which model performed well for your project, for your data?
Ma'am, SLP model and MLP model both are performing well because its accuracy is 88 point of the SLP model. But as comparison to MLP model, it is showing 81%. But the precision is showing 93%. And his precision is showing MLP model is 81%. So
So
overall,
I
if we saw
suggest
it,
try to add another layer in the MLP and add any of the other activation function and try and check with the MLP with the accuracy part if it is like increasing or not. Okay,
okay, ma'am, I will do it. I will do it, ma'am.
fine. Okay, you can
Thank
just
you, ma'am.
stop sharing your screen. Yeah, Priyanshu, you can just share your screen.
Okay, ma'am. Yes, ma'am. Is my screen visible?
Yeah, your screen is visible.
So, hello all of you. Myself Priyanshu, and today I am presenting my project, heart disease prediction using artificial neural networks. So, my objective is to build a neural network model to predict the presence of heart disease in a patient. So, I use the dataset of UCI heart disease dataset, which is the organization which collect the dataset and uh, train the model according to that data set and also clean the data set pre-processing like these things. And I used Python, KRS, and scalar library, pandas and Seaborn. And the key concept are ANN and binary classification. And in evaluation metrics, I use accuracy, precision, recall, F1 score, and ROC, AUC. Then firstly, I imported the necessary libraries like NumPy, Pandas, Matplotlib, Seaborn, Plotly, sklearn, and TensorFlow. And I use a set random seed for reducibility. Like by using this, like it is consistent for like if I run the notebook again, Then it maintains the consistency of the accuracy. Then here the overview of the data set, UCI heart disease data set, like age, sex, CP, trust BPS, like resting blood pressure, and cholesterol, FBS, resting electrocardiographic, and minimum heart rate achieved, exercise, ST depression induced, the slope of the peak exercise, and the number of major vessels, colored fluoroscopy, and the thalassemia and the heart disease, which one is for present and zero is for absent. Firstly, I loaded the data set using the given URL, uh, because it is always already clean data set. I used that. So column name, I imported the columns like age, sex, CP, trash BPS, call, FBS, REST CG, Telec, exchange, old peak, slope, CA, thel, and target. Then I imported, make a data frame and printed the shape and the information of the data set and print the few rows of the data set. Like data set shape is 303 is column, sorry, 303 rows and 14 column. And the information like data type and the non-null values are here. Then these are the few rows of the data set. Then the data loading inside the data set contain 303 sample with 14 feature, including the target variable. Feature include both numerical and categorical variable. Target variable represent presence 1 or absence 0 of the heart disease, and some entries contain missing values that will needed to handle in the pre-processing. Then I check unique values in target values, and I get to know that we have the 0, 1, 2, 3, 4 are the unique values in the target. Like 0 is for not heart disease, means absence, and 1, 2, 3, 4 accordingly, like increasing the heart issue. Then I perform the EDA. First I check the for the missing values, like in the data set, and I like CA have 4 missing values, Thel have 2, and all have 0 null value. Then the target variable distribution. Then this is the graph, like which have distribution of target heart disease according to the target variable. Like 0, we have the 164 count heart disease. Then one target have 55, and two have 36, and three have 35, and fourth have less than 20. Then correlation heat map, so the like age ratio, age sex ratio, and age CP, and so on. Then distribution of numerical feature. Now, this is the graph, like according to the numerical feature, like distribution according to the numerical features for the death. Like here, according like age 50 to 69, target is 0, and the count is 97. Like 97% die due to heart attack. And then this is the trash BPS, like blood pressure, and here is like target 0, and trash BPS is 130 to 149, and the count of the person who lose life is 65. And this is for cholesterol, then thallic, and the old peak. Then box plot for numerical features by target. Then according, this is a numerical feature which according to the target. Like for 0, target 0, age 51 to 57, and these are the ages. Then the blood pressure, like for 0, blood pressure is 138, and so on. Cholesterol and the thallic and the old peak. Then I calculate the and display the summary statistic, like which give the mean, standard deviation, count, minimum and maximum of the whole data set and the 14 features we have. Then the EDA insights are missing values, target distribution. So if the data set is balanced between healthy and disease causes, correlation, and numerical features like age, blood pressure, cholesterol, and different and distribution between healthy and disease cause suggested predictive power. Then I done the data pre-processing. Firstly, handle the missing values. So first I like handle the missing values. Before we have 303 rows and 14 column, but after deleting the column which have null values, then we have the 297 rows and 14 column. Then I convert the target variable into binary. Like we have the target variable from 0 to 4, like 0, 1, 2, 3, 4. Then I convert these values to the binary like 0, 1, 0, 1, and 0 for no disease and 1 for disease presence. Then I separate the feature and target, then scale the features using standard scaler, then split the data and for the in training like X train, X test, and Y train and Y test. Then the training set shape is 237 rows and 13 column, and testing set shape is 16 rows, 60 rows and 13 column. Then the class distribution in training set target like 0 for absence and 1 for presence. So 0 0.52% and 1 for was 0.47%. Then pre-processing inside our missing values have been removed to ensure data equality. Target variable converted to binary format. Feature has been standardized using standard scaler, and data is split 80% training, 20% testing, and class distribution in training set show the balance between positive and negative cases. Then the model architecture. Firstly, I imported the library like TensorFlow. From TensorFlow library, I imported Keras model for layers, input sequential, and dense dropout. Now the input defines the shape of the input layer. Then dense, fully connected layer, every neuron connected to the previous layer. Then dropout help preventing overfitting by randomly turning off neuron during training. Then sequential is for simple way to define a linear stack. Firstly, I define the input layer. We have the 13 feature in the data set, and then this define the shape of your of the input data for the model. Then here I create the model like input layer shape 13 takes 13 features and hidden one like 64 ReLU like ReLU is the layer property and the activation property. It means the 64 neurons and
Relu is
ReLU
the
activation.
activation function, not a property.
Yes, ma'am, means it include in a property na so yes ma'am.
Okay, continue.
Yeah, and the dropout layer 0.3. Yeah, then I compile the model, and the model summary is here. Sequential is a model, and the total params I have 3,521, and the trainable parameters I have the 3,521, and non-trainable are 0. Then model training. Here I train the model using the early stopping and the model checkpoint. It is uh, important from the carriers model. Then I use the 100 epo like in the last 96 to 900. I have the accuracy of 0.8333 and the loss of 0.65. So it is stopped in the 100 because I use the 100 echo. Then the plot training history. Here so the loss and the model loss and the model accuracy. We have two graph in the loss like epo in the x-axis. On model loss we have epos like one by one until 100. So from 1 we have the loss of 1.5. But at the end, like 100 epochs, we have the loss of less than 0.5. And in the model accuracy, we have initially we don't have the accuracy like less than 0.4, but at the end we have the accuracy of above than 0.8. Then the training insight are early stopping help prevent overfitting. Model checkpointing ensure we keep the best performing model. Learning rate and batch size affect training stability, and dropout and L2 regulation help in control overfitting. Then the model evaluation. Here, like accuracy, precise recall, and F1 score of the model. Like accuracy is 0.883, like 88%, and the precise is 0.8850, recall is 0.8833, and the F1 score is 0.8818. Then here is a confusion matrix of the model. Then I plot the ROC and ROC curve and AUC. uh, like it is a receiver receiver operating characteristic. And like if the ROC, like ROC stand for, it is a graphical representation used to evaluate the performance of binary classifier. Like x-axis have the FPR, false positive rate, and y-axis have true positive rate. In FPR, proportion of negative incorrectly classified as positive, and in the y-axis, TPR, proportion of positive correctly classified, also called recall. So the ROC curve the show the trade-off between the sensitivity and the specified for different classification threshold. And the AUC stand for area under the curve, like it area under the ROC curve. And the AUC, if we have the AUC of 1, then it is basically a perfect classifier. And if the AUC is 0.5, then random guessing. And if the AUC is higher, then the better model performance. Then the model evaluation insight are here, like performance metrics, accuracy show overall correct prediction, precision indicate reliability of positive prediction, recall show the ability to find all positive case, and F1 score balance precision and recall. Confusion metrics show the distribution of correct and incorrect prediction and help identify if the model is better at predicting certain classes, and ROC and AUC score indicate model discriminatory ability. Closer to 1 means better performance. Like in this graph, I have like 1, 1. So the ROC is best in this case. Then the importance of features and model interpretation. Like here are the accordingly in descending order. Here are the features important based on the ANN weight. So the CA is highly important in the model for predicting the heart disease. Like CA have the importance level of 0.0799, and then the thal and age, and accordingly the least importance feature is old peak. Then here are top 5 most important features like CA, thal, age, CP, and sex. Then this is the feature importance insight. Then this is the model like for new patient making the prediction. And then like I made the function predict heart disease and import the columns like age, sex, CP, trash BPS, call, FBS, rest CG, thalec, Xing, old peak, slope, CA, and thal. So then here are the sample for the data. Here I import the like age, sex, and CP, and import into the patient data frame like here. Then transfer into the model.predict to predict the future, and probability prediction into multiply by 100 to make a percent of the heart disease. Then for the sample prediction, the risk of the heart disease is 4.19 according to the given data, and the prediction is that low risk of heart disease. And here are the like some parameters.
Your voice
Then
was breaking. Can you come again with the last part?
yes, ma'am. I'm now audible.
Yeah, yeah, audible.
Yeah. So here I make a function called predict heart disease, and inside the this function I use the columns, uh, then like age, sex, and all. And then from the giver from here I make a simple data and imported this data to the data frame, patient data, and that data frame I imported into the model.predict to predict the percent of the heart disease, and multiply by 100 to make the like percent of the prediction. Like for the given parameter, I get the risk of heart disease is 4.19%, and the prediction that like show is low risk of heart disease. Then I also make the second thing, and here I also get the risk of heart disease is 2.50, and the prediction is low risk of heart disease. And the prediction inside are individual prediction, probability score, confidence of level of prediction, high low risk classification. Risk factor are age, sex, pain type, like a chest pain type, and number of vessel, often key indicator. Combination of factor, and more important that individual values like what is the age, and like sex, age, and the cholesterol level of individual person, and the resting blood pressure of the individual. Then the project conclusion is that model performance successfully built the trained artificial neural network for the heart disease prediction, and balance performance achieve the balance performance accurate across multiple matrices and ROC AUC score. And the key insight identify most influential features of the heart disease prediction, and the correlation between various health indicator, and data analysis and the model strength. Then the limitation of the data set, relatively small sample, because in the, like for the making the heart disease prediction there is a lot of data, but I use the simple for the small data set. And for binary like model binary classification might oversimplify complex medical condition and all. And the final remark are this model demonstrate the potential of machine learning in healthcare, specifically for the heart prediction, heart disease prediction. And that's all, ma'am. Thank you.
Okay, Priyanshu. Priyanshu, I have told you multiple of times, I guess, to not read from here. You can explain it from on your part, right? Just don't read from here. That doesn't look that
Yes,
good,
ma'am.
right?
Okay, ma'am. Okay.
Okay, and you have used multi-layer perceptron, right?
Yes, ma'am.
So, what was the accuracy that you have received?
And
0.883.
0.833. Yes, ma'am.
Okay, okay, got it. So have you tried and include the one or two more hidden layer inside that with same activation function or other activation function to check if you are like what is the difference you are getting?
Yes, ma'am. I use, but in other notebook, na. So
So what was the result? What was the accuracy? Does the accuracy get
final
better?
accuracy. Yes, ma'am. Yeah, final accuracy is 0.88.
Okay, so that was
Yes, ma'am.
0.88.
Yes, ma'am.
Like, is it like you have included other, like in the same model, you have tried and include other hidden layers with a different activation function, or how it is?
No,
Like, is
ma'am.
it for the same that you have discussed?
Yes, ma'am.
Okay,
Yes, ma'am.
okay, fine. You can just stop sharing.
Thank you, ma'am.
Okay. So Fida, you're there.
Yes, ma'am.
Ma'am,
You
after I can present.
after Hasini, because after Fida there is Hasini, then you can present.
Okay, ma'am. Thank you.
Okay.
Ma'am, after him, can I?
Yeah, sure, you can. Aditi, right?
Is my screen visible, ma'am?
Yes, ma'am.
Yeah, Fida, your screen is visible. You can start.
Yeah, ma'am. Thank you. Good evening, all. Today I'll be presenting my project on pneumonia screening using deep learning. So the idea behind this project is to help radiologists quickly and accurately detect pneumonia from X-ray images of chest. I worked with dataset containing X-ray labeled as normal or pneumonia. So the project covers EDA, unsupervised and supervised models, and neural networks, mainly the DenseNet CNN model. And the collab runtime here is a GPU. We have to change it here, the change runtime type from CPU to GPU. Since it's a image dataset I have, it takes a really frustrating amount of time to run the epochs. So I started executing this notebook yesterday. Um, so I got the outputs ready by today. So I won't run it again. I have the outputs here displayed. So coming to this summary, this project detects pneumonia from chest X-rays using the transfer learning technique and neural networks, achieving approximately 95% accuracy with high sensitivity. So making it clinically valuable to deploy. Objective here is to analyze the features and the patterns from the X-ray images, and then build and tune models, neural network models, in order to detect the pneumonia based on the features. So business context is we can deploy a model where for the hospitals and telemedicine platforms, which will assist the radiologist in faster diagnosis. It's like they can give the input the X-ray images, and they can in seconds they can find out whether the X-ray diagnosis gives pneumonia positive or negative. So it's a medical image analysis. Since it uses X-ray images, so it is called medical imaging analysis and a CNN based classification. So the data set I have taken from Kaggle by Paul, and it is a chest X-ray data set containing normal and pneumonia X-rays. So we have approximately 5,863 X-ray images, which has two different classes, pneumonia and normal. The image format is JPEG and grayscale, which is white and black. Of course, X-ray images we know. And image size, uh, they have varied size, but here in the project, it is required to resize the image into uniform, either 128 pixel or 224, because CNN requires a uniform input size. And the dataset has three folders already, the train, validation, and test folders. So data pre-processing here, of course, data after data collection, the pre-processing we did is resizing, normalizing, and cropping the image, like applying augmentations, and then as extracting features using transfer learning, and analysis, supervised and unsupervised analysis, and building CNN model. And the techniques used here is transfer learning, dimensionality reduction. I used PCA visualization, clustering, k-means, neural networks, CNN I've used, and data augmentation. So setting up the environment, firstly, since large data, we need large memory. CPU processing is not enough. It is much slower. So we have to shift to GPU. I've downloaded the dataset via Kaggle Hub. Kaggle Hub is a API which fetches the data from Kaggle. It may be a dataset or notebook output or other insights from Kaggle. And we have set the path into path. And again, we are creating a directory called data directory and joining the path of the dataset and naming it as chest X-ray. So then printing it. Here is the dataset exploration. Among the data we have from the Kaggle, now we are creating three directories of train directory, validation, and test directory. And we are assigning the path and fetching the train dataset from the original data of Kaggle and displaying the counts here. How in the train counts pneumonia we have 3875 and normal cases we have 1341. There's a highly imbalance in the data. Coming to exploratory data analysis, there is a limited EDA performed here because since it's a image data, not much of the numerical analysis can be done. Importing the core libraries and similar thing what we've done here, the setting the data paths and this counts images per class. This code, it counts how many images are present in each class folder. The folders are normal and pneumonia. Within the train, validation, and test, in all of the three, it counts the total images here. So from this we can see there is a high class imbalance. Pneumonia, the count of pneumonia images is higher than normal images. Class distribution plot it is. So here by this plot we can observe that even in a train and test there is higher count of pneumonia compared to the normal ones. Validation is a very small amount. We have around only 16 of images in validation set. Then here it is showing the random sample images. There is sample images of normal X-rays. We can see it is clear. Comparing to pneumonia, normal are much, the lungs are much clearer, and in pneumonia we can see foggy white opacities. It is, there is a clear separation in normal and pneumonia. The patterns are clearly depicted, so CNN can learn effectively. So image size distribution here, what it is showing is the height and width of images, which is not uniform here. We can see there are so many highs and lows here, even in width and height. This indicates the image needs resizing it to a standard resolution, to single resolution, and CNN requires a uniform size, so it is a must to resize them. This is a class distribution plot of trained dataset. Two classes, normal and pneumonia, in the trained dataset. Here we can see pneumonia class is thrice the amount of normal. So there's heavy imbalance. So we need augmentation here to get high diversity in the data, to increase the diversity. This is a PCA projection, dimensionality reduction. Here the PCA shows clear separation between the pneumonia and normal data set here. Unsupervised approach, I've used k-means clustering with PCA. Of course, it is showing us two clusters clearly separated, and the ones coinciding are not properly separated, you are not properly clustered. The patterns are missed here.
Fida, your voice was breaking. Can you just come again with the PCA part once?
Sure, ma'am. So this is a PCA projection of images in the trained data set, of course. And here there is a clear separation of normal and pneumonia data sets images. Here we can see the unsupervised approach k-means clustering used upon PCA. So it also shows two distinct clusters, mostly one as normal and other depicting pneumonia, and some coincides here, which shows some of the images are misclassified as well. Then supervised approach, I've used logistic regression, random forest, and support vector machine. Uh, Train and we split the data and the models, the accuracy, the final accuracy I have displayed here. We're getting around 93 and 95 around this accuracy. So logistic regression, it's a linear separation, and for random forest, it is capturing the non-linear patterns as well. And after tuning also, I got around same kind of accuracy for all of them. So um, yeah, this is for random forest. It's 92% and SVM as well 92 and logistic regression 93. There's no much change in the accuracy even after tuning. So the main CNN model architecture here, model type is convolution neural network. The base architecture is the DenseNet 121. As the name says, this is a deep learning architecture. As the name says 121, it has 121 hidden layers. So it works very well on image classification, and it is trained on ImageNet dataset. So it can be used for transfer learning as well. So the training details, the input data we took is just X-rays, image size resized to 224 for dense models, and two classes we have labeled as pneumonia and normal. Data augmentation we did rotation, zooming, flipping, and normalization. The optimizer I used is Atom optimizer, and learning rate was initially low. Um, and loss function I used is binary cross entropy, which is suitable for binary classification. Yeah, data augmentation. So image preparing the image generators. So the image generators, what are they used for is in deep learning, they are primarily used to feed images into a model in batches, not all together at a time. And they also help in augmentation. Augmentation is nothing but rotation or flipping or cropping, rescaling, brightness adjustment, all these in case of images. And in text, it would be like grammatical adjustment and such. Image generators are extremely helpful when dealing with large image data that cannot entirely fit in the memory. First, it converts images into correct format for CNN, and it loads in small batches rather than all at once, and it helps prevent overfitting because there are small batches, and helps in augmentation. Here the batch size is 32 and image size is 224. It is resized. So this is we have rescaled the images, and yeah, rotation, zooming, shift the range, horizontal flip we've used. All these augmentation techniques we've performed on train, validation, and test data set. This computing class weights. Here, since the data is imbalanced, the normal, which is lesser data, we give higher weights to the data which is lesser, and we give low value, low class weights to the data that is higher. Here, 1 is pneumonia and 0 is normal cases. So here the data set gets balanced, giving class weights. Building dense model. The base model I've used DenseNet. So there's a transfer learning technique I've used here, which means it's using a model that is already trained on big data set, like big data set like ImageNet, and adapting that model for our problem. Instead of starting from scratch, we reuse the model's knowledge of features like edges and shape, which has already been trained, and then fine tune it to detect pneumonia in chest x-rays. This saves time as well as gives better accuracy. So here base model I've taken DenseNet 121. Uh, so weights are from the ImageNet dataset. So we are freezing the first top layers because the top layers consist most of the information from the ImageNet, but we do not need that. We need from X-ray dataset. So trainable data set, we are keeping it frozen. And next, the layers here, global, what it does is global averaging pooling. It reduces 3D features maps to 1D, like much smaller than flattening layers. And the dropout 0. 0.4 is 40%. Randomly, it drops 40% of units in order to prevent overfitting. Sigmoid activation function I've used here, and compiling optimizer, Adam optimizer with a learning rate 0.001 and loss function is binary cross entropy, which is suitable for two class problems. And yeah, this here is the summary. This model builds a transfer learning pipeline using DenseNet 1-to-1 to extract the features. Here we can say total parameters are trainable parameters are around 1k, and mm, that is what lightweight classifier head we have. Excuse me. Here is the callbacks we need for backpropagation as well. Here the model checkpoint, it saves the best DenseNet, it saves the best model, like where it monitors on validation loss and early stopping. It also monitors on validation loss, and upon 6 epochs, if the validation loss is not improving, then it stops the epochs. And reduce learning rate upon yeah half upon monitoring the validation loss after 3 epochs. If the validation loss isn't much improving, the learning rate will be reduced by half. So this is what it says. Training the top layers, I've used 12 epochs, and the train generator we had made the batch there. Augmented data, train data is stored in train generator, and epochs is 12. Validation data is also the augmented validation data stored in validation generator. Class weights we have assigned, and callbacks assigned as well. So this took a lot of time to run. This was DenseNet models tuning, and we can see accuracy after 12 epochs, it is around 86%, and validation accuracy is 81, which is not much perfect for deployment of the model. So we'll be fine tuning it. After tuning, so yeah, after fine tuning the model, we're adding the trainable like top layers which were frozen. We are unfreezing the top layers of DenseNet and fine tuning that. Later, upon running the epochs, the accuracy went on till 97%, and also the va- validation accuracy was higher. It went on to 1, and the loss is 0.08, which is the best model I can say. So the model performance here, accuracy was 97%, F1 score is 90%, precision is high in detecting pneumonia, 95% recall that shows strong performance. Only 5% of data is misinterpreted here. So this model is ready for medical application. And evaluating on the test data, we can see for normal the precision is 95 and recall is 81, and pneumonia it is 90 precision and recall is 97. So this says like the accuracy is 91% on test data. Only 9% of the sorry yeah, 3% of the pneumonia cases were misinterpreted as normal, and 19% of normal were misinterpreted as pneumonia. That's what the confusion matter says. There's a sample inference here. I've taken from the normal test directory and the normal classes. The pneumonia probability it showed is 0.04, that is 4% of chance of pneumonia. That means there's a low risk of pneumonia, that is it is normal, the image is normal. Thus we can say the model correctly thinks this is a normal X-ray. So displaying the images, test images. So the true value is normal and the predicted value 0.02, that is also normal. True and predicted both are normal. So we can see visually that the prediction is not wrong in 90% of cases. So true and predicted values are same. Then learning curves, when we plot the learning curves, we can see there is increase in accuracy over the epochs. I've used 20 epochs, and even the validation accuracy follows the training accuracy and increases, and training loss and validation loss also improves. It moves from 0.7 to around 0.1. I've also used ResNet 50 CNN model. Here, this model consists of 50 layers. Mm, Similarly, modeling, and these are the summary. Here we have 2000 trainable parameters. And training the model, I've trained 12 epochs, and there was not much higher accuracy, so added fine tuning with adding 8 more epochs. Just Yeah, here upon 12 epochs, we had accuracy around 0.76 and 60%. And upon fine tuning, accuracy reached to 95%, and validation accuracy was 93.93%. So there is a strong memorization, there is a sudden increase in accuracy as well. So there is the chances of overfitting because there is a sudden jump here from zero point 0.6 validation accuracy to 0.93, 68% to 93%. There is a sudden increase. So the training data, the model learns the training data well, But validation data, since it is only very few, 16 images we have, so it is, I think that is not perfect here. There might be some more tuning required, or adding more data set to the validation is required. And evaluating here, we can see accuracy was 87% upon evaluation on test data, like for 87, approximately 87 accuracy the model gave us on test data. Normal is recall was 75, which tells 25% normals were misclassified, and for pneumonia recall was 94, only 6% were missed. This is feature extraction using the transfer learning for further use in ML models. So this extracts the features, flattens them, and into vectors as required for ML. This is one-hot encoding. Since the labels, the classes we have is normal and pneumonia. For single layer perceptron and multi-layer perceptron, we need numerical values like binary values. So we encoded it into 0 and 1. So for normal and pneumonia, this is the encoding done. Single layer perceptron, here activation function softmax have used, and Adam optimizer, and loss function is categorical cross entropy. Metrics accuracy upon running 20 epochs with a batch size of 16 and 20% of validation split, and the features extracted above are used here. So the accuracy went on to 97%. So it is a single layer perceptron is a straight line classifier, we can say. It shows only linearly separable problems. Like for example, if we give the input x-ray, just x-ray features, the output will be normal or pneumonia, that's it. But it can't capture the complex patterns present in the x-rays. So upon evaluating here, we got the accuracy 98%, and single layer perceptron accuracy is 97. So the loss decreasing, the model fits training data well. Like I told you, it is a straight line classifier. The complex pattern won't be identified from this. So the best suited is multi-layer perceptron. So it has one or more hidden layers between input and output, and it uses non-linear activation functions like ReLU and softmax, sigmoid, tanh. It learns the complex and non-linear relationships as well. Like for example, input the CNN features from VGGNet, as we took the input, the features here, and hidden layers like around 128 to 68 neurons it takes. Output will be normal and or pneumonia, but the model can subtle patterns in lungs like the opacities or the textures. Also, here we can see the accuracy went on to 1% up on epoch 9. Yeah, after epoch 9, the accuracy is shifted to 1%. 100%, sorry. And but validation accuracy is still 93%. So this shows a slight overfitting in the data because it has the model learned well on the training data set, but on validation it is still missing somewhere. So SLP, that is single layer perceptron, gave decent accuracy, but it was limited, whereas multi-layer perceptron performed better because it could capture more complex patterns. And next, the model deployment plans. What we can do is we can use cloud services like Azure for deploying the model. We can create a website or a mobile application or clinical setting in hospitals for radiologists to assist the radiologist. Just they give the chest x-rays as input, and they can detect whether the x-ray has pneumonia or not. And APIs can be built for users to upload their x-ray images and look for predictions. Conclusion, here, pre-trained dense net 121 model performed best for me as it has 121 layers. The model is good for image classification as well, and the features, it extracts the complex features which are required to train the model perfectly. Augmentation and transfer learning is a must in case of using densenet 121 model. So a future enhancement that can be done on this model is fine tuning the densenet model again, and with stronger augmentation. Then uh, class imbalance, yeah, handling class imbalance is important, like we did using class weights. And exploring more ensembles means we can combine two or more models that will boost the accuracy and deploy clinically. And yeah, that's all about my project, ma'am. Thank you.
Okay, Fida. It was a great attempt from your end, seeing all of it that you use the supervised as well, non-supervised, the pre-trained one as well, and also the single layer perceptron and the multi-layer perceptron. So multi-layer perceptron did had a tendency of getting overfitted, right?
Yes, ma'am, because the validation accuracy was
Right.
not higher. There was a sudden like jump here as well. From 5 to
Right.
8 and 9, the sudden jump. And the validation dataset is only 16 images it has. So if we add more images to
Yeah, it might
validation
change.
set,
Right.
it might change. Yeah.
Yeah. Okay. Okay, Fida. It was a great one from you. Okay. You can just stop sharing.
Thank you, ma'am.
Next is Hasani. Hasani, are there?
Yes, ma'am.
You can just share your screen and start your presentation.
Ma'am, is my screen visible?
Yeah, it is visible, Hasani.
Okay, ma'am. Good evening, everyone. Myself, Hasini. Today, I'm going to present my project, which is emotion detection from the text. Uh, Firstly, I'm going to develop a model which is detecting and classifying the emotions expressed in the user text into various categories like sadness, joy, love, anger, and etc.
Hasani, sorry to interrupt you, but your voice is not clear. Like there is certain echo that is coming up. That's why your voice is not coming clearly. Can you
One
fix
second, ma'am.
this?
Yes, ma'am. I'll reconnect, ma'am. One second.
Yeah, yeah, okay.
Ma'am, now am I audible?
Yeah, yeah. Now it is better.
Okay, ma'am.
Yeah, you can continue.
Okay, ma'am. Good evening, everyone. Myself, Hasini. Today, I'm going to present my project, which is emotion detection from the text. Basically, I'm going to develop a model which is capable of detecting and classifying the emotions that has been expressed in the text given by the user into various categories or the emotions like sadness, joy, love, anger, fear, and etc. into 6 different classes. And we will be analyzing the context of the user generated text by using a deep learning technique, which is a convolution neural network, that is CNN model, and enabling the various applications in present society, like by improving the sentiment understanding in chatbots and social media monitoring and engagement analysis also. I have considered the data source from Kaggle, which is an emotion dataset. Firstly, I have installed the required libraries like TensorFlow, Scikit-learn, and Pandas. Then I have imported the libraries, which are tokenizer, patch sequences, and classification report and confusion matrix from sklearn. And then I have uploaded the dataset files. In my dataset, I have 3 different CSV files, which are training data, validation data, and test data. That are the CSV files. Next, I have loaded the CSV files into their respective data frames as train DF, validation DF, and the test DF. Next, I have displayed the sample data for each data, which is training data. In each dataset sample, we have the text column and the label column. Text depicting the user defined data, and the label depicting the various classes like or the emotions, from 0 being the sadness until 5 being the surprise. Next, I have labeled the text and label columns as the text column and label column, and use them for the pre-processing. Coming to pre-processing, we have previously converted them into a data frames. Sorry, loaded them into a data frames as train data frame, validation data frame, and the test data frame. And I have concatenated them using the concat function and labeled them as a all text. Now the vocabulary size is 10,000, and the maximum length of the data is 100. Then I have used the tokenizer by using a token which is out of vocabulary token, and then fitted them using a tokenizer.fit on text. Next here I have performed the text encoding function where this function will be taking a data frame as input, which is df. From this here it performs conversion of the text data into the sequences by using the text column data frame. Then over here I have performed the padding operation on these sequences with the maximum length, which is 100. And by assuming the padding equals to post, we'll be checking whether these are of same dimension or not. On performing this encoding function, here on the X label, I have performed the data preparation, and on Y label, we have performed the label preparation by using the label column. Over here, this encode text has been performed to various data frames that are train, validation, and the test data frames to create the respective X train, X validation, and the X test. And over here, I have performed the label preparation on Y train, Y validation, and the Y test, extracted them from the label column data frame, and then converted into the integer type values. Over here, by using the np.unique, we will be calculating the number of unique classes that have been established in the Y train and stored them into the number classes. Over here, on performing the one-hot encoding, we will be converting the integer data values into the binary encoded matrix of zeros and ones. Now we will be performing the 1 second. Okay, now
here is the model architecture. I have used the convolution neural network model that creates a neural network for text emotion classification. Here, firstly, in the CNN network, we will be having three major steps that are embedding, flattening, and dense. And at last, we will be performing the dropout. Now, on performing the embedding, the input dimensions and output dimensions are considered for embedding, and then flattening is performed, and dense is performed by using the ReLU activation function, which is a rectified linear unit on 128 dimensions. And here 4% is the dropout, and performed on dense is performed by 126 128 and 64 dimensions. And then at last dense is performed basically by using the softmax function. And at
Your
last we have
voice
come.
got broke in between. Can you just repeat this section, please?
Okay, ma'am.
Yeah.
Here I have built the model, which is a convolution neural network model for text emotion classification. Actually, we'll be having the three major steps under the convolution neural network, which is embedding, flattening, and dense. At last, we'll be going for the dropout. Here, for the embedding layer, we will be converting the words into the dense vectors on performing the flattening. And then the flattened data will be processed for the dense layer on using the ReLU activation function, which is rectified linear unit on 128 dimension and 64 dimensions. And at last, by using the softmax activation function, we will be compiling. Sorry, by using the softmax function, the dense layer is performed. And at last, the model is compiled by using the categorical cross entropy loss and by using the ADAM optimizer to train the accuracy of the model. And here is the summary of the model being generated. Over here, here it depicts the total parameters, which is 2.9 million. And then here we can see that embedding layer consisting of the 128 dimension. Here each word of the text given by the user will be mapped with the 128 dimension vector of length equals to 100, and then flattening is performed on this 128 dimensional data, and then dense is performed for 128 and over here 64 dimensions, and dropout is performed with 128 dimension. And here we have the trainable parameters as 2.9 million. And at last, they classifies the input into emotion categories using the softmax activation function. And next, we'll be performing model training, where the training is performed on the training text data, which is X-train, and on the one-hot encoding emotion labels, which are white train, and performed for 10 approaches, which are number of passes we will be iterating over. And it uses the validation data, which is X validation and the Y validation one-hot encoding. On performing one pass or the one epoch, the accuracy is 36%, and the validation accuracy is 70%. On going through continuous epochs till 10th epoch, we have the accuracy as 99% and the validation accuracy as 84%. Next, the model is evaluated over here, and I have predicted the probabilities of the X test data. And argmax is performed to convert the softmax probabilities into the class labels of axis 1. Then I have depicted the classification report and the confusion matrix by using the sklearn metrics. I have imported them over here. And then the classification report and confusion matrix are being generated by using the Y label, which is Y test and Y predicted datasets. On visualizing the classification report, we have it provides the class specific metrics for the model performance. Here the metrics are precision, recall, F1 score, support, and accuracy, macro average, and weighted average. Firstly, the precision is the ratio of the correctly predicted positive observations to the total predicted ones. Recall is the correctly predicted positive observations to all the observations we have been generated from the data observed on the dataset. F1 score is 87%, which is the mean of the recall and precision values, which here we have observed for 87%. And support is the actual occurrences of each class or the each emotion we have seen in the dataset. So here for each label from 0 to 5, the precision, recall, FN score, and support metrics are being depicted over here, and the accuracy is 84%. Macro average is the weighted average of the precision and the recall for each label over here. Weighted average is the average of precision, recall, FN score, and the support across all the classes of, and weighted by dividing with the support of each class. So over here we have 78% as the macro average. Weighted average is being 84%. And here we have seen the confusion matrix. Confusion matrix here summarizes the performance of the CNN model by comparing the actual class labels over the predicted class labels in a format. Here, each row will be depicting the instance of a class or one emotion. Over here, for example, let's consider the 512 as one instance under the zero class label, which is sad emotion, zero being the sad emotion. So here the diagonal elements over here, like 512, 603, 106 till 40, will be representing the number of correctly classified instances for each class. So 512 instances for of class 0 are depicted correctly as the 0 label, which is sad, and the off diagonal, which is remaining elements rather than the diagonal elements, represent the misclassifications in the data set or the model. Here, where the model is confused for one with one class for another classes, so the remaining values are depicted like this in the confusion matrix. So here we have displayed the sample predictions on the test data. So I have considered the 10 sample predictions with text column, and the actual label and predicted label are been displayed over here. On considering the uh, first text over here, which is I am feeling rather rotten, so I am not very ambitious right now. So here the it's been a sad emotion on the user. So the actual label is depicted as 0 and the predicted label is depicted as 0. So which means the model has been predicted class 0 for the text and they recognize the emotion as sad. Let's consider for this text, which is I can't walk into a shop anywhere where I do not feel uncomfortable. Here it depicted the actual label as 4 and predicted as 4 itself, which means the 4 label is considered as fear. So there, for user, the model has been predicted as correct, which is a fear emotion. And in the same way, the remaining text data samples have been considered and predicted as the same ones. And this is the description of that examples. And at last, I have used a bar chart in the horizontal format on depicting the emotion label distribution. On x-axis, I have considered the count of the labels of the text data in the dataset and the label number from 0 being the sadness and 1 being the joy, 2 is love, 3 is anger, 4 is the fear, and 5 is the surprise. On the scale of 0 to 5, these emotions have been considered. And in the data set, 1 is the highest emotion the user has been generated within the text data set with 5,362 instances for joy emotion, and the least being the surprise. So, on final conclusion, this CNN model has been effectively learned the patterns of emotions like sadness, joy, anger, and etc. within a labeled data set from Kaggle we have considered. So, on performing the various phases like training, validation, and testing, it has been achieved accuracy of 99%, and the classification metrics have been shown above, like precision, F1 score, and etc., confirming its ability to identify the emotions from the text inputs. So, this is the emotion detection from the text project by using a deep learning technique, which is a convolution neural network. And thank you.
Okay, Hasani. So, you have just taken down the sample and just plotted it down like the based on that, what is the actual with the predicted, right? So,
Yes,
that
ma'am.
for all of the set, it predicted accurately,
Yes, ma'am.
or is there any misclassification?
Yes, ma'am. There is a classification. Like overfitting is performed, ma'am. Like we can see above, the validation
Right.
accuracy is 84%, ma'am. So there is little
Okay.
bit of overfitting. Like few text
Yes,
data
there
set
it is.
can be misclassified.
Right, right. So, it is also suffering the overfitting kind of issue, right?
Yes, ma'am.
But apart from that, it has like apart from that, the validation accuracy I've got around 84%.
Yes, ma'am.
So we can consider that the like in terms we can try and consider the accuracy level is getting around more than 80%. In that
Yes,
terms, if
ma'am.
we can think of, right?
Yes,
Okay,
ma'am.
okay, got it, fine. So that is fine for the internship and this project. But if you want to just make it better, you can just try and use any of the pre-trained models that is there. You can just try and check with any of the uh, like pre-trained model that has already been there. You can try and use that and see or fine tune it with the formations
Okay, ma'am.
and
I'll
see
do
if
that.
how it is actually working. Okay.
Okay, ma'am.
Okay, fine. Okay. So, okay, fine. Okay, Hasani. So it was a good attempt from your end as well.
Thank you, ma'am.
Okay, fine. So Himanshu and Aditi, you are left, but today we are running out of time, so you can just present tomorrow accordingly. Okay. So tomorrow we
Yes,
again
ma'am.
have this. Yeah, tomorrow we do have the presentation session again. So tomorrow first you do go ahead and present your presentation. Okay.
Okay, ma'am.
Okay, ma'am.
Yes, ma'am.
Uh, yeah. Okay, fine. So we'll
Thank
just
you, ma'am.
wrap up our session today here. Okay, fine. Bye, guys. Bye bye. Good night.
Bye, ma'am. Bye.
Bye, ma'am.
Bye, ma'am.
Yeah,
Thank
bye
you,
bye.
ma'am.
Good night, ma'am.
Thank you. Bye bye.